Hello everyone, my name is Ashley Valise and this is my presentation on consumer or energy. For this presentation, I decided to discuss sustainability. I thought that this was the most interesting and most relatable for me, so this is the one I decided to go with. Okay, the agenda for this presentation, I will start with the introduction. Secondly, information on utility companies, issues on um, analysis and artificial intelligence, solution analysis part one, solution analysis part two, ethical concerns, and my discussion with a summary. Okay, introduction. When overseeing how utility companies can actually maximize sustainability using artificial intelligence, there are many options that come to mind. Sustainability has become such a priority across many different industries, but most importantly for utility companies. Utility companies provide such fundamental energy and infrastructure needs as major contributors to carbon, as major contributors to carbon arise, these companies feel an immense pressure from regulators, investors, and customers to take an environmentally sustainable practices. These practices include artificial intelligence and specifically digital twins, which is a virtual representation of real-world physical object systems or process. This technology can accelerate and advance sustainability efforts in the utility division. The term artificial intelligence refers to computer systems that can perform tasks normally requiring human intelligence such as visual perception, speech recognition, and decision making. Utility companies generate large amounts of data sets across customers, distribution structures, and power generation assets. Artificial intelligence can ultimately create a number of possibilities from all the knowledge and information being created. Digital twins, as previously mentioned, is an important tool for sustainability and will eventually become more important as the push for cleaner energy continues to grow. By creating virtual replicas of physical systems, digital twins enables a deeper understanding and control over difficult energy networks, helping to maximize management and maintenance aggressively. This type of digital mirroring can drastically replicate and ensure that we are forecasting accuracy and for renewable energy sources. This will help create a more stable, sustainable, and predictable energy landscape. Even though there is no silver bullet for sustainability, artificial intelligence constitutes a more adaptable instrument to conduct the challenging, urgent, and high-stakes orchestra of interests that converge in delivering sustainable utility services. Information on utility companies. So utility companies have been utilizing artificial intelligence for sustainability, and been advancing throughout the years, but not as rapidly as one would think. Even though artificial intelligence is recognized, utilities have been slower to fully embrace its capabilities due to the factors like risk and complexity of their operations. Future trends include increased use of artificial intelligence for grid optimization, predictive maintenance, and resource management. When discussing risk avoidance, it is meant that utility companies tend to be more cautious about adopting new technologies even when those risks have significant potential. This can be understandable given the fact that new trends can be scary to get into. The complex nature of grid infrastructure, asset management, and customer interactions can present challenges in implementing and scaling artificial intelligence solutions. Utilities often deal with vast amounts of data, but ensure its quality and accessibility for artificial intelligence algorithms can be a significant hurdle. Finding and retaining skilled professionals with expertise in both artificial intelligence and the utility industry can be very challenging. There are a lot of new and future trends utility companies have adapted. These are key reasons why we should continue to grow sustainability in utilities. Utilities are increasingly exploring generative artificial intelligence for tasks like customer service, operations, optimization, and infrastructure planning. Artificial intelligence is being used to optimize energy disruption, improve grid reliability, and integrate renewable energy sources more effectively. Artificial intelligence algorithms are being used to predict equipment failures, optimize maintenance schedules, and reduce downtime. Artificial intelligence is being applied to optimize water and energy consumption, manage waste, and implement sustainable practices. Artificial intelligence is also playing an important role in developing smart cities, where utilities work together to optimize services and improve sustainability. Lastly, artificial intelligence is being displayed at the edge of the network closer to the source of data to improve real-time decision making and responsiveness. So, in conclusion to the slides I just went over, the core business values that analytics and artificial intelligence address in utility sustainability is optimizing resource use, reducing waste, and improving efficiency across the utility sector to minimize environmental impact and operational costs. This mostly includes areas like energy generations, distribution and consumption, waste management, and water usage. The utilities are directly impacted by the need to reduce costs, improve efficiency, and meet sustainability targets. Customers benefit from lower costs, more reliable services, and a healthier environment. Stakeholders like regulators and investors are directly impacted. Lastly, the environment is overall impacted because the reduced resource consumption and waste is positive for the environment. Optimizing operations can lead to significant cost savings for utilities, reducing resource consumption and waste can directly contribute to a more sustainable future. Meeting sustainability targets and reportings on ESG metrics is increasingly important for utilities and their stakeholders. Utility companies that effectively leverage analytics and artificial intelligence for sustainability can gain a competitive edge in the market. There are many problems, however, that can occur including energy generation and disruption, optimizing renewable energy integration, demand response, and grid management can also be a problem. Another problem that can occur is with the energy consumption, predicting demand, optimizing, building energy management, and promoting energy efficiency. There could be an issue with water management as well because it involves water usage monitoring, leak detection, and water disruption optimization. Another problem that can occur is with waste management, where optimizing waste sorting, recycling, and waste to energy process. Okay, so now I'm going to discuss the solution analysis. The integration of artificial intelligence and analytic solutions for utility sustainability can be examined utilizing the steeple analysis framework. I went ahead and used the chart. For social, I wrote public perception and acceptance, integrating artificial intelligence in utilities can raise concerns about privacy, data security, and potential job displacement, especially in areas like automated meter readings or grid management. Customer engagement. Artificial intelligence can provide consumers with personalized energy usage insights and recommendations, potentially empowering them to make more sustainable choices and reduce their carbon footprint. For technology, I wrote workforce impact. While artificial intelligence can automate certain tasks, it also creates new job opportunities for skilled professionals in areas like artificial intelligence development and maintenance, and for those working in green transition. Smart grids and energy efficiency. Artificial intelligence powered solutions are critical for optimizing energy disruptions and consumption on smart grids, reducing waste and enhancing reliability. This includes applications like damage forecasting, predictive maintenance, and optimized energy disruption, minimizing waste and potentially reducing operational costs. Um, Integration of reliable energy. Artificial intelligence is vital for integrating and managing renewable energy sources like wind and solar, helping utilities better balance energy loads, predict generation patterns, and optimize energy storage. Predictive maintenance, artificial intelligence driven predictive maintenance can monitor equipment performance, detect anomalies, and prevent costly failures, improving system reliabilities and reducing energy waste. For economic um, cost reduction, artificial intelligence can optimize energy production, disruption, and consumption, leading to reduced costs for both suppliers and consumers. Artificial intelligence powered systems can streamline processes, reduce energy wastage, and lower maintenance costs. Investment opportunities as businesses recognize the benefits of artificial intelligence in energy management, investments in in advancing these technologies are likely to increase. Um, Market dynamics, artificial intelligence can contribute to optimizing energy trading, strategies by analyzing real-time data on pricing, supply, and demand. Environmental, reduced carbon emissions. Artificial intelligence can significantly contribute to reducing greenhouse gas emissions by optimizing energy consumption, improving energy efficiency, and facilitating the transition, to renewable energy sources. Resource conservation, artificial intelligence can help reduce the use of resources like water and minimize chemical runoff, as seen in the example of optimizing irrigation and agriculture. Data center energy consumption, while artificial intelligence offers numerous benefits for energy efficiency, it is crucial to acknowledge the energy consumption as artificial intelligence models themselves, particularly during training. Addressing this requires the commitment of using renewable energy sources for data centers and developing energy efficient algorithms. Lastly, for political, I wrote regulatory landscape. The adoption of artificial intelligence in utilities is influenced by evolving government policies and regulations. Navigating this landscape effectively is crucial for artificial intelligence companies and utility providers. Incentives for innovation. Governments can incentivize artificial intelligence adoption in energy management through policies that promote sustainability practices and invest in artificial intelligence driven clean energy innovations. International cooperation, addressing the energy demands of artificial intelligence and ensuring a sustainable energy future requires global collaboration and the sharing of knowledge and best practices. Okay, solution analysis part two. While specific environmental regulations for artificial intelligence are still emerging, exiting frameworks and potential legislation can influence the usage of current artificial intelligence analysis solutions in utility sustainability. Environmental Impacts Act. Although a relatably new bill, this act could require utilities to study and report on artificial intelligence environmental impacts, including energy consumption, resource use, and electronic waste. Data protection and privacy regulations. Regulations like GDPR in Europe and NIST in the US mandate responsible data governance practices which are crucial for artificial intelligence systems handling sensitive consumer and operational data. Sorry, I'm getting a little tired. Artificial intelligence regulations focusing on safety and security. Existing and emerging artificial intelligence regulations often prioritize protecting consumer and business interests and safety, which is especially important for critical infrastructure like energy sector. Okay, transparency and accountability requirements. Regulatory frameworks may mandate transparency in artificial intelligence decision making and require clear accountability for outcomes, ensuring responsible artificial intelligence deployment. Thank you. Okay, so what are the ethical concerns? There are several ethical concerns and issues for business leaders deploying artificial intelligence in utility sustainability. Artificial intelligence algorithms trained on biased data can actually worsen existing inequalities, leading to unfair or discriminatory outcomes in areas like energy disruption or resource allocation. The collection and use of large amounts of sensitive data by artificial intelligence systems also raise concerns about data privacy and the potential for breaches or misuse. Artificial intelligence can also create a lack of transparency and explainability. Another ethical concern can be the job displacement and workforce transition. Business leaders also need to address potential for artificial intelligence driven jobs displacement and invest in retraining and reskilling programs for affected leaders. There are also environmental impacts of artificial intelligence to keep in mind. Organization needs to consider the the energy and resource consumption associated with artificial intelligence, implement sustainable practices, and seek ways to minimize artificial intelligence environmental footprint. There are several geographic limitations and global implications to take into consideration. While AI analytics solutions in utility sustainability are not inherently limited to specific geographic areas. Their implication and effectiveness can be influenced by various factors. The availability of accurate, diverse, and representative data is important for training effective AI models, and data availability can vary depending on the region and level of infrastructure development. Another area to keep in mind is how diverse national and regional regulations concerning data privacy, AI governance, and environmental standards can impact AI implications and cross-border complications. Lastly, we should take into consideration the local, environmental, and socio-economic conditions. There are challenges like extreme weather events that can influence the design and application of AI solutions. Some global implications to take into consideration is the increasing demand for computing power and the associated energy and resource consumption of AI development and deployment. There is also potential for increased global energy demand. The widespread adoption of AI could potentially increase global energy demand, requiring careful consideration of its potential impact on energy security and the transition of low carbon future. In conclusion, artificial intelligence holds significant promise for enhancing utility sustainability, but their deployment requires careful consideration of the manif- manifested external factors encompassed within the steeple framework, addressing potential ethical concerns and navigating the evolving regulatory landscape are crucial for unlocking AI's full potential for driving more sustainable and equitable future energy. Okay, so in conclusion, artificial intelligence presents a powerful and potentially transformative solution for enhancing sustainability in the utility sector. By leveraging AI's capacity for data analysis, pattern recognition, and predictive modeling, utilities can achieve significant gains in areas like energy efficiency, grid management, and resource management. However, the implication of AI solutions is not without its challenges and concerns. The implications include data privacy, insecurity, transparency and biases, and emergency consumption. My outlook for the longevity, I'm sorry, of artificial intelligence in utility sustainability is optimistic but cautious. While artificial intelligence's potential for is undeniable, its long-term success hinges on the proactivity um, and addressing its limitations. The actions that would be prioritized to make AI truly sustainable would be developing energy efficient AI models and hardware, ensuring data quality and biases mitigation, promoting transparency and explainability, fostering collaborative and knowledge sharing. AI should be a powerful tool to accelerate sustainability. It needs to be used responsibly and ethically, prioritizing and well-being of both people and the planet. Thank you. And these next slides are just references. I can leave these here for a little bit. Thank you.